Hello everyone. Mm, well, this is an tutorial for designing this hollow core slab. Many designers have confusion in this hollow core designing slab, which software generally they use and how it is designed. So it is designed in Concise Beam software, which uses ACI code, and you can change the code as well. So let's start with the designing process. So let's take an example of a 12-meter span for designing 12-meter span for a commercial complex where the live load will be of 4 kilonewton per meter square, and superimposed dead load will be of 2.5 kilonewton per meter square. So let's start. First of all, you need to go to this option button where you can choose the design code. From there you can choose this many codes are available. So generally we this hollow core slabs are designed as per this ACI, which is American Concrete Institute, um, where 31811 is used for this code. So okay, then we opt for this unit of measure, like in which unit you want to work. So I'm in India. In India, generally we use these all units for several input data and other output which we want, like deflection, force, moment, stress, and stress area per length. So, okay. So now it is me asking me like where you want to save this. So let us save it on desktop. Where no, wait a second. Let's save it in another folder where we can name it as tutorial. Okay, here we can give it name of like 12-meter span hollow core slab. So here you give the name to the file. Now you can other combinations should remain same, like if we are designing as per ACI. Now you need to define these code. You have defined the code, and now you have to give this beam definition is there, and the concrete material is there. Like first of all, you need to define like which grade of concrete you are going to use for hollow core slab and the screening material. So if you see here, that precast beam means whatever hollow core slab double T beam you are designing for that. So we generally design it for 40 MPa. So it is 4000 kg per meter cube. Sorry, it has to be 25,000, which is the density of concrete we generally take. The Then we give the grade of concrete, like which grade of concrete we want to use. Then this is this has to be remain same, like this is an strength of concrete which we are going to apply at this stage of transfer. Like at the age of transfer, it means that while the uh, hollow core slab is going to transfer, at that time what strength of concrete do you require. So that strength of concrete we have to give. Generally this is 70% of what concrete strength is there. So if you calculate 70% of 40 comes down to 28 MPa. So we have to give value to it likewise. So during initial stage, and at the transfer state has to be same. So we change this to 28. Then cast in place pour, that is for screeding concrete. Like screeding concrete, we also take 28. So everything remains in monolithic. Okay, so everything else has to be remain as it is. So okay, then you go to beam definition. Under beam definition, there are several options like select section from the library, create new section, whatever section you require. Then it is the section properties and trim or edit section. So first of all, let us take predefined section. There are several sections in this library. So if you select this section, there are several manufacturers and other American manufacturer who already has a different kind of hollow core slab. So let us take an example of this ultra span, which is having 250 mm thickness and width of 1200. So okay, we have given this definition to it. Now here you can change the name from 251202 to ultras ultraspan 250 mm. 250 mm. Yes. So now you have to give this a segment length. So we have decided to give 12 meter. So we'll give it 12 meter. And if you are having any lateral offset or vertical offset, then you can provide it here. So first of all, let us keep it as it is, and let's modify it. So whatever section you have choose comes down to here. Now it is okay. Then these all are the supports, like where you want to give the support. So I mean, how much bearing length you require to support this hollow core. This shows that. So at the left of the end of the beam, we want 0.2, and at the other end we can 11.8. Okay. So, and this is the state of transfer. Support center, it transfer from support center in service form. So here also let us choose 0.2 and zero point 0.8. Then this bearing length they also want. So bearing length which we want is let's take to 75 mm. Okay. Then there is also a beam handling parameter. Okay, wait a second. These let us not change this. No, let's take it. No problem. Beam handling parameters are also there. So this is regarding lifting of beam. So this take in account the lifting of beam, like when you lift, what all loads will be coming to the beam at what position. So let us define this. Left end of the beam has to be at 0.6 meter, and from right end also we want 0.6 meter. Every other thing has to be in same. The beam transport, we also want this the same 0.6 and 0.6. Okay, and every other thing has to be remain same. So we'll not change the any other parameter. So okay, now all the prerequisites which are supposed to be given in the software we have given it. Then you can see this checkbox which will be, you generally have to give yes. So here we have got the diagram. There's a small mistake over here. Let's change it. You can see that this support has shifted to 0.2. I don't want that. I want it, let's go to beam definition. Let's keep it 0 and let's keep it 12. Let's keep it 0. Let's keep it 12. Okay. Here is just to be 75 and 75. Okay. So now you can see. So now you can see that this 75 support we have given. Initial bearing we have given. Okay. Now let's move on. Now we have to give this CIP pore definition, like what thickness of screeding you want. So generally 75 just for diaphragm action of whole building, as a whole slab, I mean whole plan slab. So let us provide it 75 Generally this is very uh, critical thing, where the width, generally the bottom of the hollow core slab used to have 1200 thickness. The above top face is generally of 1198 So these parameters will give here. So check it out. So add it and modify it. So it will automatically take the which what of concrete is required to do this. And okay, another thing, torsion parameter. If we are having this any extra torsion and other things, you have to calculate and give it over here. But right now we are designing it only for vertical loads, so we won't give it. Now self load, self weight is generally automatically calculated by Concise. Then we go to applied loads. Uh, yes, this is a main parameter, like first first group load label. So let's give it to dead weight, beam weight. It will be dead load factory produced. It will be initial lift to initial lift. Okay, and it has to be sustained load. You add it, under this you add the, not, you don't have to go this load cell beam weight. It will take automatically whatever the vertical load, the concise will calculate the values. Then other thing which we give is first is beam weight, then comes CIP pore, that is dead load general, that is CIP placement to CIP placement to final service. It will be under dead load general. Give it added. Then comes the superimposed dead load. That also has to be under dead load general. No, wait, that has to be under live load general. Okay, sorry. Dead load will be under dead load general only. This will be final service to final service, and for that we have to give area load, which is 2.5 to 2.5 area load. Okay, we have added it in this. Then comes the live load. Live load will be under this live load general. Hello general, and this has to be transitory because these won't be sustained load after the hollow core slab is placed over the beam erected, and after that these live load are going to come, so we have to give it transitory. So okay, add, and under this we have to give an area load of 4 kilonewton per meter square and 4 kilonewton per meter square. Okay, modify. So now we have defined it, beam weight, CIP, and live load. Okay. Other things, we do not require other things. So let's go to, okay. One more parameter which I have forgot is this load combination. On this load combination, we have to provide everything to one, modify it over here. Then as far as since I'm in India, uh, we have to delete all the other loads. And since not in India, but we are not providing any other kind of load, like it is not going to be on roof, it is no rain load we are applying, no snow load we are applying, no wind load we are applying, no wind ultimate level earthquake as these frame structure. This is frame structure, so we are not giving any earthquake load to this slabs. We are giving it to column and beams only. Slabs will be only for vertical loads, so let me delete all those. And these parameters, since we are not using any controlled fluid, so we'll change it to 1.5 to live load 1.5, 1.5 dead load plus live load. Okay, so here it goes. Okay, so now we are not giving any reinforcement steel, so all these has to be remain at it is. Don't add any of these over here. uh, if design requires this reinforcement steel, if the length of the hollow core slab is too much, then this has to be provided. But right now, in our case, for 12-meter beam and for 2.5 kilonewton per meter square SIDL and 4 kilonewton per meter square live load, we do not require this. So let us not change it. And then you have to give this pre-stressing force, like right now let us start with 10 strands, 10 strands. uh, Generally keep in mind that in this whenever you design this hollow core slab, this stress ratio at lock off should never be above 70, 0.70, 0.70. So initially you start with 0.69, then what cover you require, let's keep it 35. Then you can change the this strand parameters as per available in your local area. So in right now where I am, we are available with this 12.7 mm dia, where area is 107.7 mm square. So I'll take that and change this to 12.7. Okay, whose string value is 1860. Now let me add. Then as per design, I want two strands, at 70 mm distance. I will add that also, and I want two strands at 215 distance from the bottom. So I'll add that also. So here you can see these all the in red it is showing the most bottom strand, then above that, then the top strand. So this is my design requirement for the hollow core slab. So I have given all the parameters. Now I'll check to OK. Now I'll go to shear strengthening. If design it requires shear strengthening, I'll show you when to check this shear strength and how to give this. Just keep all things 0. Okay, right now we do not require. We'll check certain values from the design report. If that design report is okay, then we won't change here. If in design report we are getting some values different from what is required, then we'll change this shear string. So uh, for this design report, let's not change it. So okay, this design parameter, yes. So in design parameter, do remember that these total losses should never go beyond 25%. So right now I'll keep it use predefined losses. So I'll check it over here. Use predefined losses. Okay. So it has to be calculated as per ACI. Mostly cured. We are not using heat cured. So right now my slump, I don't want any slump. I'm taking cement of 380 kg per meter cube. Air and range to 5%. Full total aggregate should be for 0.4. Fine aggregate to total aggregate. Aggregate size, yeah, I'm using is 20. Direction is okay. Relative humidity should be 70%. Ambient temperature is also 28%. And exposure of interior, since I'm here using it interiors only. So right now, stripping stage will be right now what we are using is 3 days. For this, we are using initial lift gate 7 stage. Transported will be at initial will be at 4th stage and transported at 7th stage. Casting for 14th day. Total action completed in 30th. And this completion you can change to this. It has to be 30 days and above. I'll keep it at 31. And, okay. So done. All the parameters we have provided. So everything is per the requirement. So now let us see the design report. We will check this summary report, so everything will be checked under that. So this is a design report of hollow core slab. section properties. This is a pre-stressing detail. So this is the main thing which values are supposed to be given to the manufacturers from the structure designer. So what we have given right now is 10 quantity of strands of 12.7 mm dia whose cover is 35 mm has to be, and whose tendon area, total tendon area comes to 1077 mm square, has to be stretched, at 1382 kilonewton. So yes, there's a mistake over here. The top strand we don't have to go to 0.69 to change the stressing. Third one, keep it to top strand are not required to stress that much. So maybe 30% is okay. Okay. Now we go to design report. Okay. So these are the value which you required. These are the main value. From these value we'll calculate the elongation of these strand and other parameters. Okay, right now it is showing that two legs are required, but I don't want it, so I will change the some parameters and this will come down to 0. It's not required any. Okay. Now you can see here that beam weight has been calculated automatically by Concise. CIP, that is costing power, has also been calculated automatically by us. This CIP power, CIP weight. Okay, this is SID and we need to change something. Applied loads, CIP. Okay, we need to add SIDL. I don't know why it. Okay. So replacement to final service. Okay. Add this 2.5 plus 4, and this CIP will not require any load. So okay, CIP is calculated by Concise only. CIDL 2.5. Yes. Okay. Yes. See this SIDL has come to 2.5, which we have given. The CIP core has been calculated automatically by Concise, and the slab load is what we have provided, 4 kN square. Okay, and these are the combinations related to earth which we have applied. So you can see the stress values over here, ULS and SLS. These are the combined support reactions which will give to this beam. These are the concrete stress result. These are the only uncracked analysis. If you see longitudinal tensile bar needed, so required provided additional, where these top beam at X mirror stresses this much and this much, over stress notice 0 0 0. If here, if there is any value, then we have to provide reinforcement, but since here is 0, no longitudinal reinforcement is required. Here you can see that beam not cracked, cracking is controlled, or crack is less than the concrete curve. So these all parameters are okay. The main thing which we have to check out is this thing, deflection. So if we see that at the stage of transfer, this camber will be of 22.4 mm. At the time of erection, the camber will be of 38.9 mm. Then the completion stage, 3.1 mm camber will be there, and when dead load will be applied over it, the deflection will be there. If you see here, negative shows the deflection and positive shows the camber. At the time of dead load final, there will be deflection will be there, and at this stage of final dead load, which live load, um, if you see this 46.1 mm is there. So this is below than permissible. If you see here, that is span to deflection, what deflection is permissible is length by 240. So here if we calculate 12 meter by 240, then it comes down to 50 mm. 50 mm deflection is allowed, and here it is coming to 46.4, so it is okay. Even though if you want to decrease this, then we can increase stress by a little bit, or we need to increase the thickness. So right now it is okay, right now it is under permissible. This is the main check which we need to do. So this is okay, and all other things are also this. Everything has to be under tension only. Nothing is to go under compression. So everything is okay. And if you see that warning and notes here, they have mentioned B. B means warning that Mn is less than 1.2 cr. And Mn is less than 1.2 cr for this medium reinforced requirement not met. So what we will do, extend at x is equal to 0.2 to 0.96, 1.760. So what we'll do, we'll provide a filler in the course, shear reinforcement, where we do not require any 0 modify. We will define, we don't want this. No shear, no reinforcement for shear, no reinforcement for shear, but will shear calculation options are available. Include bursting steel? No. We want to fill pores for shear strengthening. Beam is a part of slab. Okay, and define it. Let's start with 28 MPa because everything we are doing that only. And this has to be during composite pour from limit 0 to 12. No, we want till 0.2 symmetrical. Provide it here, and let's right now do it this. So okay, um, so now if we check, okay, now it is okay. Now it has been changed to A. Okay, now everything okay is as per the requirement. So now let us check out the graph. First of all, need to see the flexure requirement. This is the designed moment, which is showing in red, and dotted line is minimum strength required. Uh, it is minimum this much is required. Designed strength, what we are getting, it is totally above that. So in these all portion there are some problems, but that has to be rectified and there has to be down. Now let's see the shear design. The shear design, this little bit is there, but that has to be rectified. So we have to rectify that. Now let's see the deflection. If you see the deflection, it is totally okay. Dead load per slide or maximum limit is -50, and maximum we are going what is coming from actual load is 46.31. So this is perfectly okay. So here is your total design report of hollow core slab.